Okay, let's summarize once again. So what we are studying is SNS and SQS. SNS and SQS. SNS, SQS first. Okay, let's start SQS. So the model is it's pull message. So the consumer pulls the message. Consumers pull. Consumers pull messages. In SNS, messages are pushed to consumers. Different. Another difference is SQS, a message is processed by one consumer. By one. Here, a message is sent to many consumers at the same time. What else? The maintenance pull and push. Fan out, yeah, fan out is like what this guy is. There's a slide for that? Yeah. Oh, cool. Wow. Okay. Okay, cool. It was the summary. Anyway, so let's like let me draw one architecture diagram that how we can use this SNS SQS EC2 all together. Our problem statement is, let's say, okay, let's just make it simple for now. You have a message, and that message is processed by two applications at the same time. Okay. So for that, at the same time, what we can use is, okay, there's a request coming here. There's a producer in here. Producer. And since it said like two applications at the same time, we can use SNS. And then it can publish to app1. So I will say like one or maybe consumer. I can call it consumer one. And it is. SNS, and this is consumer one, and consumer two. This is app one and app two. And now notice here, I will not call it, it's not that, it's naming is like in programming all the bits. Naming is same person, I'll call it this. So this is publisher, I would say. Publisher is publishing a message to SNS. And now, so I renamed this on purpose, but now notice here, this is, let me erase it once again to make it. Okay. Step 1 and that. Okay, this one makes sense, right? You have a message and you want to process that message by 2 applications at the same time. So how we can design that application is using SNS. Publisher sends a message. Publisher can be like application, another application that sends message to this topic, and then it sends to the other applications. Now I want you to focus on this part. So this is, in this case, this SNS itself is, it's producing message. SNS produces message, and this is directly pushing to this services. Do you see that as SNS? Okay, from publisher to app1. So this call is, we know that this call is asynchronous because we use this topic in between. Now, if I look at not the whole picture, but only this picture. You look at here, SNS is pushing messages to these applications directly. It's not asynchronous. So from topic to application, it's directly. And what I see is like, so now it's same as the request response model we have said. SNS directly pushing this topic, directly pushing this message to app1. If app1 is down, then you will get an error in here. Get an error. So for this, and then we know the disadvantages of this request response model. And then here we can make this connection. So this one is asynchronous. This one is synchronous. So this is synchronous. We can make this call asynchronous by pushing message to a queue instead of, we put queue. If we put another queue, then now connection from SNS to app1, it's asynchronous. So that's like one thing. Why that queue as a protocol there? Like to me, yeah, it's, he asked that question, and yeah, I also had the same thought. Like, why queue? It's like, it might be correct, might be wrong. I don't know, but this is like I noticed during this lunch break, right after the break. Because now between publisher and app1 and app2, it's asynchronous for sure, because we have topic in between. But the topic itself and the application, it's synchronous, it's directly pushing. So, and then we have some issues with this synchronous model. So we want to make it asynchronous so we can introduce a queue. One small thing. Another thing, it's my opinion. If I design my application, then what I would do is I would create a queue for each application, for each application. So for example, I have this standard one, producer and queue and application one. And if I need to add another application, a new future, new application, I will not do that in this way. I think you can do this way using that message attribute to publish the message, and in the message attribute you can do like app1, app2, or you can use group, something like. But when you do that, the logic in this queue, this one gets complex. So the thing I always keep in mind when designing application is, I talked in the first place, simple solution for complex problem. I don't want to like make my queue complex, or I don't want to make my producer complex. I don't want anything complex. I just wanna make it simple and just use this existing server. So then what I would do is I have this producer and it's pushing to Q1 and then F1. And then same thing, Q2. And to me now, like now this this Q component is now not complex. You don't have to have that groups or message attributes. It's less complex on this here. You see that, right? But then again, you are making your producer complex because you need to write like if as a statement. If it's F1, then send it to Q1. If this request, like inspect the request first, if it's going to F1 or F2. So you have to write if as statements. And writing if as a statement, that makes things complex, right? And then that's why we have that general type in Java. In Java, like you have that general type. So basically, we programmers, we avoid using if as statements, basically. You do that, right? You follow it. So for that reason, now you know it, right? So here, producer and like what technology you can use. This is 2 messages. You can use SNS again, right? You can use SNS. And now here, okay, this is first variation. So I talked about the issue with this variation because there would be complex logic in here. Second variation, we have this variation, and then this producer gets complex. And I want like simple solution for complex problem. So third option, what I can do is I can use SNS or event bridge. And not only me, like many organizations, they are using this approach. So event. So basically now your producer dumps all the data in here. Like producer, send all the data to this event bridge. It doesn't. There is no logic in it. Producer receive a message, pass it to this event bridge or SNS. So now it can send to Q1 and Q2. And then application 1 can listen. Application 2 can listen to it. There is no logic in here. Or this there is no logic. Our queue, it's simple. And then nothing gets complex in here. Like you don't write those if as a statement. Here, and then how you inspect your messages. So your message is in here. Your message is here, like all the messages. And here you want check this message, inspect this message, and if it's M1, then you can type something like filter or rules. You can write something M2. In SNS, you can you can like now your logic is like navigate these events to your destinations, right? It's based on that maybe event type. If it's order placed, then you wanna navigate to a system for order placing. If it's shipping, then you wanna do that to this, navigate to different application. So here, and then that logic, we do that in the SNS or in Bridge, but we write like some filtering here, filter orders that you can change at runtime. So you don't have to change anything in your code. You don't have to write any if-else statement. Instead, you are just using this pre-built services. Like Cirrus is there. Here, no code, right? Our code was here, like our task was to, and then we are approaching this using this services. Okay, anyway, this is the idea. One thing that some students might get confused is, again, as I mentioned in the first phase, I prefer using one queue for one application. So here, your queue, it will look like this. And then F1, F2. So we don't, like, I won't do this way. This is not good practice. I won't do that. Instead, it would be only, okay. Instead, it would be only F2, F1. This is Q1. This F1 can have multiple instances. This is queue application. It's a queue for application 1, and application 1. This is hosted on EC2 instance, and this is hosted on EC2 instance. Application. So this is EC2 instances running inside maybe auto-scaling group. Application is the same, but in your one application, you have multiple consumers. So this is the correct way to think that. And when there is a message in here, it will be consumed by either this instance or this instance. If it's purchased by the second EC2 instance, then this message is hidden from the first EC2 instance. So basically, so we talked about many consumers, right? Many consumers essentially is one app running on multiple machines, multiple EC2 instances, or multiple lambdas, or multiple tasks, container tasks. Does that make sense? Like one consumer.
So it's for queue or for the same?
It's for queue. For queue. SNS it sends to all. For queue, we talked about like one message, one consumer.
Even though there are significant from either market.
Basically, here what's happening is you have one queue, only one queue, but then you do have many consumers, but here that one means like one consumer purchased this message. That's what I mean by one and many. So your application, it can run on multiple machines. Do you follow that? Like you scale, your application is hosted on EC2 inside of scaling group, and now you have multiple EC2 servers listening to this queue. What I mean by one is like one of them will purchase one message at a time. If it's purchased by the first EC2 instance, then the other two cannot see that.
Yeah, that's exactly my question. So, so if the two instances are accessing the queue, which means if it could be in the active MQ or other messages. If the message is received or processed, but the other one couldn't see because it will be deleted or it will be hidden.
Yes.
So in this case, what actually gonna read the AC2? The other subscriber or the filter. If the message is done, there will be anything to read. So what I'm trying to say is, let's say the first one is read, and if the first instance read all the first messages, what's gonna happen? The second instance, there won't be any message to read because everything will be taken from by the first.
Okay, very good question. I really like it. So basically, okay, this is app one. That's a very good question. I love that. So, okay, this is same app called app one. I differentiated by this color because this is like two different instances. You're running the same app on two different instances. So just go. So you have this message 1, message 2, message 3. Let's assume that if this guy is processed by the instance 1, then the second instance cannot see this message. And if second instance, this message 3 is also processed by this first instance, then this cannot see. Similarly, if second instance is processed by second message processed by this second instance, this A1 cannot see it. This is how it. This is like what I mean by one message, one at a time. His question, yes, this is correct. Now notice here, all these messages are purchased, and there is nothing in the queue, right? In that case, yes, this EC2 is listening to this queue, waiting new messages. Now let me tell you one thing. This SQS, it's AWS service, so there is metrics, default metrics. One of the metrics you can get from SQS is number of messages. This metric is there, it's there here. So for example, at 2 p.m., there was this number of message. After 1 minute, there was one message, but after another 5 minutes, there are even more messages. So you do have something like this metric, maybe here, then it goes back. When you have a metric, you can set auto scaling group policy, right? So basically now, based on this number of messages, you can scale your servers. So for example, then it creates a threshold, something like this. If number of messages less than this number, then you want to remove one of the instances because it's just there listening to a queue. There is no message. So then there is no point of having that instance, right?
It's not balancer. You can consider.
Load transfer is not applicable in this case because load transfer is you are making request and EC2 is processing. In this case, this EC2 instances, this A1, this application one, it's not receiving any request from load transfer. Instead, it's receiving the message from the queue. It's pulling the message. The model is pulled, right? It's not in load transfer. It pushes the clients push messages, so servers handle. This is the other way. So that means like it's not applicable. You don't need load. It's like a bunch of EC2 instances that's responsible for doing some computation. And then what it can do is maybe.
So both two instances of application one are pulling at the same time. One got M1 and M3 and other got M2.
Yes. They all are like this. There is a connection between your EC2 application and here. In Java, there is, I think they call it GMS. Java. This is how you do it. Messaging. And here component, there's it's like GMS listener annotation. So that means like it's not handling the request. Instead, it's listening to that queue to see if there's a new message. It's like there's a one active condition always there, and then it's listening the queue to see. Yes.
In case of SNS, SNS will push messages to load balance.
Yes, exactly. That's correct. Because it's push model, right? So it can push to SQS, or you in the slide you have seen that there is this HTTPS. 1 second. So it can push message. It can make a request like a client, and then that HTTPS means it's your load balancer link. Okay, and it looks like, again, I repeated this. There's only like 2 things that you need to keep in mind, but the meaning is it's like deep. It's something is. Right. Anyway, go here, I think. Let's do some hands-on. Too much. So let's implement what we have just discussed. Microservice 1, it sends with create a lambda, it sends message to a queue, and that queue triggers a lambda. It's like exception, I guess. In the diagram, if you have Java application, if you have non-lambda application, then it listens to a queue. But in event, since lambda is event driven, it's AWS that like AWS can trigger lambda because like it's managed by AWS. Okay, so basically it's still okay. The arrow is pointing to the microservice too, but the idea is still there are 2 ways basically. There is a message in the queue. Yeah, microservices here is always sending message to here. There are 2 ways to get it in microservice too when it's lambda. If it's not lambda, then there is only 1 way. You have to listen to that queue. You have to pull the messages using libraries like JMS and Spring. Okay. Lambda, it's an exception that lambda can listen to the queue, or this queue can trigger the lambda. Okay. There's just exception anyway, but basically it will send message to a queue. That message we will receive in microservice 2, and this microservice 2 will send us an email through SNS. So here we will gain some hands-on experience with above queue and SNS. Let's do this. Makes sense? Just simple payloads, just flowing through these components. It's very simple demo. It's like hello world. These 2 services. Okay. So we do have queue. Refresh. SNS. I'll go to Lambda. And I will create 2 Lambda functions. I create two Lambda functions. One is called microseries1, and I'll choose node 16. So there is okay, it's out of topic, but let me tell, like yesterday I worked on this. I prepared next task. I prepared yesterday, and then I learned like bit about this Node.js 16 and 18, and there is a big difference in here. When you choose Node 16, I'll put it in here. There's a big difference in here. When you choose Node 16, it uses AWS SDK version 2. And then all my code is, I prepared this months ago. So my code snippets are for this AWS SDK version 2. But when you select your runtime, maybe not 18, it looks like it's not a big deal. You are just selecting the next newer environment. But then when you do that, AWS Lambda uses AWS SDK v3. Does that make sense? No? Okay. Okay, makes sense. Okay, good. AWS SDK, it's with Lambda. From Lambda, we can call other AWS services. To call other AWS services from our application is using soft SDK, software developer kit. And there is these two versions. If I create this Node 16, and if I copy and paste my code snippet in here, do you see this AWS SDK? And I wrote some code in here. It's a code for V2 SDK. In SDK V3, it's like major version, they use TypeScript. But this V3 uses JavaScript. So I have to change my code completely. This is your extra bonus task. You can, if you select Node 16, Node 18, and if you write this very simple two API calls using TypeScript with this AWS SDK 3, then I will give you the credits, but 1 or 2 students. Okay, that's the reason why I have to select this Node 16.
How can we get the focus?
Yes, very good. It depends on which runtime. Now, it depends on which runtime, right? If you choose 16, it's V2. If you choose 18, it's V3. So you can simply AWS SDK, JavaScript, V3, and V2. Do you see here? Yes. If you're going forward with V3, yeah, I highly encourage you go forward with this V3 and help me to get my code updated. And then just click on this, and you will see here AWS SDK, and the service we will be using is SNS. Do you see here? If you click on SNS, then all the documentation in here, and we will use only one function in here, publish message. Publish, not command, message, send message. Okay, 1 second, let me. And this is SNS, it should be publish. I think this one, publish command. Okay, I selected SDK v3, I selected SNS, and I selected this publish because we are publishing this. And then you can get scrutiny. It sends a message to SNS topic, and you have to provide like which topic and what message. That's the only two attributes. Sending message to queue, it's exact same. You have to provide which queue and what message. Okay. If you selected V2, then same thing, just Google for it. And if this is the KV2, SNS publish. Not here, there should be some documentation. I think this one. Yes, this is how the V2 documentation look like. SNS, it's a V2 and SNS, and here you should be able to see this publish sends a message to SNS topic. It's the exact same. And click on this, and here you will see like what parameters are required, what you need to provide. This is how you will write your code. And since it's second week, I'm not giving you any code. Okay, this is something, just look into these two documentations and build your own command, like all you build your own function. So this is, I think, V2. V2. And copy and paste this guy. I also include V3, and this is recommended. And what I need to do is go ahead and change this command. I predict. Okay, that's it. Okay, let's go back to here. So because of that reason, let's go back. I have to select node 16 and use existing role. The only way to do that is tab role. And I will repeat the same step. I will open up this, create my second function, microservice 2, and node 16, change role, use existing tab role. Yes, that's it. Should be it. Microservice. Okay, cool. Since it's AWS Academy account, this lab role has all the permission to send publish message. But if it is non-AWS Academy in a regular account, your personal account or your work account, one thing you must to do is you must add those IAM policies. So let's just do that. We cannot create this because of these other issues that we all know, but just let's build this and see how the JSON looks like. Okay, before that, it looks like I need to, like when we create IAM policy, we define which resource, right? So we need to create the resource up front so we can copy and paste it in. Here, I'm going to use existing queue. You can create new one. I'll use this my standard. For SNS, let's see. I don't want to use this one. I'll create new one. SNS and SQS. Anyway, just does. So you give it a name. That should be it. And here, do you see? We already know what P4 is, what the standard is. Like you have that option in SNS. We studied this, we know that, so I will skip this. Okay, cool. So we created this. So this is the SNS we will be using, and this is the queue that we will be using. And here, let's create a subscription. Protocols. Wait, create subscription. SNS P4. Okay. I didn't realize that I selected this before, but I just learned a new thing with you. When you select before, it looks like the only protocol is SQS. Interesting. Really interesting, but that's not pretty much. No, this is. I haven't looked into this before SNS in detail, but I know how before queues work, so then I can get some idea.
I think you should use some.
Yeah.
What do you think that is?
Oh yes, Christmas only SQs. Interesting. Okay. Anyway, this is related, and I think it's a new published last year. I think. I'll create my topic. Assignment demo. And now here I can create subscription. So here, the email, and this is your email. Says 516 at posted. Create this. Posted. And we received the subscription. Okay, confirm it. Okay, basically now we have now what we have done so far is payments coming up. We constructed this. We created this and we created subscription and we confirmed that. So we are done with this part. And we have done with these parts as well. We created them. We created them. Now the pending part is establishing these connections. So right now, like these 3 resources is scattered in the cloud. So we want to connect this. So IAM or something like that. So yeah, I know that it can do it by the default academic account, but let's just do it. Okay, that's where we are at right now. Let's come back to here. IAM. Create policy. So we will create policies. So basically, the best practice is we create an IAM for each Lambda. M1 has its own role. Lambda 2 has its own policy. That's how we do it. So basically, if it was real life, then we would have two rows and we would be writing 2 policies. In this case, I'm interested in how the syntaxes looks like, how we can build that with this UI. So here, SQS is the one. And then we want to write. And then we want to send message. Send message. And on which resource? The resource is, so it expects SQS ARN, Q, ARN, I think this one. The first one is SQS. So if we add this policy to that Lambda's role, then it can do this action. So that's one thing. Second thing is we do have SNS. SNS.
I think this permission to log in.
We are supposed to do that, but Labroad already has all the permissions, and we cannot create this policy. We get those errors. In this class, unfortunately, we can practice identity-based policies. It's not possible because of this permission boundary. I talked about this. If you got this permission, then you can add admin policy to your Labroad, and then you can do whatever you want, right? Then there is no restriction. So that's what permission boundary is. Yeah, I do have this boundary and
So what are we doing now?
just practicing.
Yeah, but what kind of policy are we having? Just inline policy or?
Inline policy. We're creating policy. Okay, isolate SNS, and we want to publish message. And on which resource? Add ARN, and this ARN is here. Copy and paste it in here. Add. Okay, I'm done with my policy. So this policy one that I would add to my first lambda, policy that I would add to my second, and how it looks like in JSON is, it looks like something like this. Or basically, I can. It's supposed to be this way. 1 second. Here, allow microservice1 to send message to the queue. So this is send message, and the resource is which one? This. No. And this is allow M2 to publish message to the SNS. Here
Should be read.
it should be read.
Second.
Second one. Publishing message.
Oh,
The other one is like this one, sending message. Second one, publishing. That's it.
I mean, the second one should be able to read from the queue.
Yes. But since it's Lambda, we have two ways.
Oh,
Like AWS can trigger it. So we would use that way. Yes, like yeah, we can do that way. Like we can add receive message. Then anyway, so write this as your homework, just write this and copy and paste this in the submission PDF. You just practice this. Anyway, let's go back now, assuming that we created this policies, gave it to the IAM role, and now our connection is successful. M1. Okay, now we can write our code. So let's write our code. In my case, I've used this. So to write this code, refer the documentation and come up with your own code. Okay, do not. So there's nothing kind of copy and paste. And do you see this code? Is it better now? So we imported the SDK. We are instantiating the SQS, and then we have send message. And I checked the documentation, and it looks like message body is required. So here I would put, I can read it from test event, or you can put some hard coded text for demo. But so it's reading that message from the event, this event, that event you can provide. And then here it requires QURF, like which queue you want to set. And that you can see that okay, here, URF is here. Copy this. Okay. That should be it. That's it. Very simple, right? Just instantiate this again, then provide these two parameters and should be it. Deploy. Okay, I have to create new test event. Yes. And here we are supposed to write one message in here because we are sending message out of this payload. So message, hello, SNS and SQS. Save it. Send it. Let's trigger, let's run. Success. Let's check our queue. There should be message. Oh, here we go. Then we got the message. Cool. Now we established connection from M1 to Q. And now I wanna this lambda, we wanna run when there is a message in the queue. So you can add something called trigger. To add trigger, like when we want to execute this. And here you can select SQS. SQS. And here you can select the queue. Which one? Is it the queue? I think so. I use this queue. And this is like how many messages. It's a batch. How many? That's it. That should be it. If you want, then you can add filter criteria. Like you don't want to receive all the messages. Instead, you want to receive some certain messages. You can add this. So that's pretty much all. And let's see how the event looks like. Console.log JSON.stringify event. Okay. Now we established the connection from the queue to M2. M1, it will send message to the queue. And when there is a message in the queue, it will trigger this lambda. Good. Now I mentioned let's do one more test and let's see how the event object looks like so that we can know the path to our message. That message is what we want to see in the email. Let's test once again. Test. Check all it went. Let's see now there shouldn't be any message. That's the looks like it worked. And then I think there were two old messages, one new message, and I think in our batch, it sent all three messages together. So, cool. I think it's expected. So it's expected. I think it was triggered. Let's check out the log. Okay, notice how I'm doing. Like you should do this step by step because I've seen some students, they do all in one and then they have no idea like which part they are making steps. Notice that. Okay, M2, it should be log stream. And this is the request. We see this. It records message ID, body, it's hello world. And okay, looks like we got this, but what about the other two messages? Is it? It's not here. Then it, yeah. Search log code. Need to start and So I don't see those two messages in this lambda. And also I don't see that in the queue. Anyway. Okay, here I logged this out to see the path. It looks like event and then it has records. And then this is an array. So events, records, and we get the first request. And well, the first one is our message. And then inside that we have body. So basically, okay, please pay careful attention in here. Like this event object is vary depending on who triggered this lambda. And then here, this is correct, right? Is it where the message is? Records first element. body records first. Okay, so this is our message that, okay, we want to receive an email. So for that, I do have my code snippets. Okay, event records 0, but okay, I already. Similar thing, AWS instantiate is SNS, and we call publish. And the message is we're extracting the message, the very first message. And then we are putting that to the topic. Oh, I think I need to replace this. Here, topic is it SNS? Yep. Topic A and copy this. So you have to put topic A and paste it in here. Is it correct? It's like it looks super long. Why is that? This is because of subscription. Okay. Assignment demo. This looks better. Copy. Okay, looks more promising. SNS. So to this topic, we want to publish the message. And then success. Check your email. Should be it. We're done, I think. Let's do the final end-to-end test. Just test it. Success. End to end. Where is my stable? Yes, I think it worked. Now let's click on that. It received recently, so it's hello, SNS and SQS. Good. So this is like how what event-driven architecture is. If you are using this system, that's what event-driven architecture is. This is, unfortunately, it's outdated way. So, guys, they make like hundreds, thousands of developers working on AWS. They're making changes every single day. And even the trending architecture, I'm sure you heard of low code, no code. Have you ever heard of that? Like if there's no code, then it's so many benefits. Like there is no need to manage that code configuration, all those environments. This is and writing tests, and this is a lot of them. What if we achieve the same result without writing any code? I would like to show you this to you all. Before this class, I didn't illustrate this, like my demo ended here. But this class is special, and I want to give you like that grasp of this no-code solution. I joined Sterling as a Java developer, and then I learned AWS, and last 2 years, I didn't write code to build my backend. I just was trying the services. And then I want to show you this, like how you can do this. The exact same thing, but with something called the step functions. You might notice, like in we discussed that if there is like not completely A and B, if you have C, D, E, and then you have this in between, you have a SNS SQL event bridge, then now you would end up having many components in the cloud. Many components, like here, I drew this, Like here, that choose 1, 2, 3, 4, 5, 6 components. And that you can see all in like now these many components you can orchestrate is using a step function. Again, I will do the exact same thing. Lambda function, you send a message, send data to you trigger this lambda with some data, and then that sends message to SQSQ, and then it reads that message and sends that to the second lambda, and then we publish email. Following exact same code without writing any code. So currently we have wrote this code. I don't want to write it. I don't even want to write this code as well. This step function, it already has AWS SDK installed in it, so you can make this API calls. Okay, let me show you this. Step functions. Coordinate distributed applications. Distributed applications, service application, event-driven, that's what we are doing in this class. Yeah, AWS functions, assemble functions into business critical applications. So I see this function orchestrator that makes it easy to sequence AWS Lambda functions and multiple AWS services into business critical applications. Okay, I'll just show. Wait, let's refresh my token. Okay, I already prepared one. I'll just run that to you and give you some idea, and then do it. You can do it at your home. Like once you got the idea, then. The second task is, if you remember the S3 event notification task. Do you remember that? And that's do the same task, but with event bridge. If you have any questions on this, then you can ask from Dana. She is sitting here. She has done this task. Okay. The functions. Okay, I created this yesterday. So okay, let me first show you then. So here, I just drag and drop. If you want to add new, like Lambda is used for running some business code, then you can just simply drag and drop. Or if you want to do like conditions, like based on this condition, you want to navigate to your Lambda 1, otherwise navigate to your Lambda 2. That you can just drag and drop and then associate with this another Lambda on this root 1 maybe. Here. Here, drop the state here. You drop here. And then you can also do this parallel work. Parallel. And then you can maybe, I don't know, maybe run another task in another. You just drag and drop. And then once you do that, you associate this Lambda with the actual function. So I put the actual function name here, step 1, step 2. You just drag and drop and you do this. And now let me show you. Let's start new execution. The message we sent was message hello step function and Lambda SNS SQS. Like we are practicing all the services together. Start this. And how you will look like is okay, so basically it like goes one by one. You can see it in real life that how your data is forming. If it had that rule condition, and then you can see like which condition is going through. And in your Lambda one, this is the message you received. And in this is the input, and the output is my Lambda one injected this attribute. So it's transforming that data. And then it's sent now. This output is the input of the second step. Input is I put this message to this queue, and this message is stored in the queue, and then it was successfully stored, and then I received this message ID for this message. Following, and then after that, now we know that there is a message in the queue, and now this step function can put the message. The pull message is done in here. Now that's basically what's doing is like there's a message and the step function is pulling the message, and what it had received is message ID. I think we should see something like plot. Okay, anyway, so it put the message and passed that message to the second Lambda. Second Lambda received this message, and this is how the body looks like. And then it injected this second attribute, and then it sent this output that I injected this output to this SNS to publish a message, and then it published the message, and I should have that in my email address. So let me double check like which, go back to SNS, and the topic it's running is this one. So if we go to SNS, and then here you can do like for each step, if you want to transform your data, then you can do that, no issues. Select this input. You can do filtering here, or you can do data transformation here. And then if there is an error, you can also add error handling, that dead letter Q. You just do this and drag and drop. So this is the actual result that I associated, and here I used this, and it has one subscriber, this guy. Let's check this email. Spot table. This is the email. This we received. This is something I tested yesterday, and after 19 hours today, and here we do it. And you receive your name. Inject better. It looks like I have some hardcode. Anyway, you receive this message. Now, do you have the idea? No code. I just drag and drop, and then I put like input. In the input, like it's receiving what's from the output, and then that's pretty much all. What you have seen so far is that's what event driven is. Okay. Event driven architecture here. Okay, this is the key idea here. And if you are wondering about pricing, then it will talk about millions. First million messages, it's free. It's almost free. And now the entire population in my country is 3 million. So So then using the zero-day resources for applications in such a small countries, they don't cost anything. And then after that, every 1 million message costs only 40 cents. SNS is similar, like first 1 million notification to mobile, it's 50 cents. And if you are sending message to a load balancer, then like it takes $60. And then if it's email, it costs this way, like 100,000 email, only $2. And you can even use simple email service, then it's even cheaper. Yeah, bottom line here is it's always free. There's always free tier that you can send on mail. Okay. Certificate cap. Yes.
You assume that this space is, gonna have